Okay, for homework, we will be going to this PhET simulation for the equation of state of an ideal gas. We're going to click on ideal and look at what we have. There are some things we can do. We can pump in particles. If I click on this plus, I can control the particles here as well. I could reduce the number of particles or add some particles. You see that we've got a pressure gauge and a thermometer. We also have this, which allows me to change the volume. And I have this, which allows me to remove some particles. Of course, I can also remove by lowering this. The final thing to point out is down here we can add heat by dragging this up. So I'm adding internal energy to the gas. Or I can drag down to cool the gas and remove some of that kinetic energy of the molecules. Finally, there's this thing I can check for width. And this technically for the simulation, because it's not 3D, this value actually is supposed to represent the volume. Okay, so that's how it works. The final piece is you can choose what stays constant. If I click right here, I can no longer change the volume. And even if I add heat, that's not going to do anything to volume. It will only change the pressure. And look at that pressure rise. If I click here, the temperature stays fixed and I cannot change this. I can't add or remove heat energy. So what happens if I expand? The temperature did not change from 512. Still 512. If I click down here, I keep pressure fixed, but there's two ways to keep pressure fixed. The first way means that you change the volume. And so watch what happens. If I remove some, if I add some particles and I want pressure to stay constant, oh, the lid popped off. Hang on. Let's do this. If I add particles and now I'm going to keep pressure fixed, and then let's take particles away. Here's my challenge. Pause the video. If I remove particles and I want pressure to stay constant, should the volume increase or decrease? Haha, it decreases. See that? Finally, you can keep pressure fixed but allow temperature to change. So watch what happens now if I remove particles. There are fewer in here, but I want the same pressure. Should the temperature rise or fall? Let's see. The temperature is rising. See that? See if you can explain why this happens using the kinetic molecular theory. Okay, so this is how the simulation works. Your task is to investigate 3 relationships that are implied by the equation of state of an ideal gas. For example, maybe you ask the question, how does a change in volume impact the pressure? And perhaps your second one is, how does the number of moles impact temperature? And finally, perhaps you're doing, how does the, how does the temperature affect the pressure? Remember that the other variables have to be constant. So in the first case, N and T would be constant. In the second case, in the second experiment, what's constant? P and V. And so you have to figure out what needs to stay fixed and make sure you code that into your simulation. All right, the other thing to remember is that whatever you put as your x-axis, your independent variable, you need to control that one and change that one in kind of specific manipulated ways. So for example, if I'm doing this first experiment, the volume I would record in nanometers. Well, that's kind of weird to say, but that's how the simulation is built. The pressure I would record in pascals. And so let's see, I want to keep N and T constant. So let me click on temperature is constant. Now I need to change the volume. How do I change the volume? Well, I'm going to click right here. Well, first let me record my first data point. The volume currently is 8.4. Oh. The pressure is 79 79? Maybe 78.9? I'm not sure. You'll have to make a judgment call. And now let me change the volume. The new volume is 6.7. The new pressure is 98.1. Hard to say. And then I continue. 9.4 and 70.2, perhaps. I'm just going to go quickly here. I'm not being very careful. 10.5. And what's our pressure? 62.8. Hard to say. You do your best. One more and then we'll make the graph. All right, 12.5. And I should have been increasing this at equal increments if I was doing a great job. Or at least close to equal increments. Okay, and the pressure is 52.67. Okay, and I'll do that for 3 experiments. I'll collect my data, and then I will add a scatter plot. For the scatter plot, all we need to add, we're not going to worry about uncertainties right now. We need to add axis titles. The y-axis here was pressure. In pascals. And it's fine to use your iPad Excel version. That will be sufficient. This would be volume B in, as weird as it is, this is being measured according to the simulation in nanometers. And you could call this experiment 1. That is your homework. Repeat this for 3 experiments. So you choose 3 different relationships from the equation of state of an ideal gas and submit your Excel file to Schoology.